Hi, so this is our review for the first RQA. So let's get right into it. The first one just gives us a position time graph. I can't stress enough that we need to really pay attention to what the axes are, okay? So this is a X versus T, so it's a position versus time graph. So because of that, the slope of this line is going to tell us, the slopes of each of these lines are going to tell us the velocity. So because this first section here, nothing's, the slope is zero, therefore the velocity is zero, therefore it's not moving. So I would say for that first section of the graph, the object is not moving. So the object does not move for the first 2 seconds. And I know it's 2 seconds because I can just look at the scale. This is 5 seconds here, so that means it's 1, 2, 3, 4, 5. So this is at 2 seconds. So then, after 2 seconds, the object travels at a constant speed. The object travels at a constant speed. I know it's a constant speed because it has a constant slope. So it doesn't ask me to calculate it, so I can just say from 2 to 6 seconds, object moves at a constant velocity. All right, so that takes care of letter A. So let's move on to B. So now it says, what's the instantaneous velocity of that object at the following times, at 1 second and 3 seconds? So this is, it looks more confusing than it is. So they're saying at 1 second. So I know the velocity from 0 to 2, that is a constant 0. So I know if it's 0 from here to here, that means exactly at this point, it has to be 0. So ultimately, what this question is asking is, can you find the slope of the line? So let's do this one here. So it's asking for velocity. Average velocity is going to be the same as instantaneous in this place. So that's what I want you to find, the average velocity. It's our change in x over our change in t. So our change in x is 0 meters over 2 seconds, which is 0 meters per second. So then for the next one, it says at 3 seconds. So I want right here. What's the speed at that point? The velocity at that point is the same as the velocity at any point. It's a constant velocity. If it's constant, it's not going to change. That means it's going to be the same here as it is here, or here, or here, or anywhere along here. So just like before, I'm finding the average velocity. It's our delta x over t. So I'm going to choose any 2 points on this graph. Now here's where it's a little ridiculous too. So I know that this graph starts at 0 and it's 2 right here, right? So it's 2 right there. There are 1, 2, 3, 4, 5 separate sections, right? So that means if I go 2 divided by 5, it's going to be 0.4. So that's 0.4, that's 0.8, 1.2, 1.8, or 1.6, sorry, and then 2. So I can just go from this point to, I don't know, go this point. This makes it 2.4. My delta x is 2.4 meters over my change in t. My change in t only goes from here to here. So that is 4 seconds. So 0.6 meters per second. Then it says, what's the average velocity for the entire interval? So for the entire interval, it's really from this starting to the ending. So if I just draw my line from there to there, right? What's the slope of that line? So that's the velocity equals delta x over t. My change in x is still 2.4 meters, but now it took me 6 seconds to do that, which gives me 0.4 meters per second. All right, lastly, it says on C part 2, it says, on the graph, draw a motion of a second object that starts at a distance of 1 meter and reaches 2 at the same time as the first object. So that means I'm going to start at 1 meter, which is, I don't know, right around in the middle there, and I need to get up to 2. So right about there is where it's going to be. So this red line I just drew. So it starts here, the y-intercept here is 1 meter, and it reaches the 2 meters right there. All right, so that's the first side. Let's move on to the second side. So that says graph the relationship between velocity and time for that one above. So I don't want the original one. I don't want the new one that I did. So from 0 to 2 seconds, we know from 0 to 2 that this thing went from, it didn't move. So my velocity here is going to be 0, okay? So it's 0 for those first 2 seconds. And then after that, it says we calculated it goes 0.6 meters per second for the next 4 seconds. We need to figure out a scale. So the scale will vary here. Like I just did my scale like this. I just went from 0.1, and each one is to be 0.1 up to 0.6. So then my velocity here is just going to be this 0.6 for the next 4 seconds. So then letter E says, from the velocity time graph, determine the total displacement of the object. So the total displacement is the area under the curve from this graph. So since from here to here, there's no area in there, that's 0. So all I'm looking for is really the area under this part of the curve right here. So that area is just going to be base times height because it's an h. So because it's just a rectangle. So the base is 4 seconds. The height is 0.6 meters per second, which gives me 2.4 meters. Which, if we take a look, our other graph should show that we did get 2.4, which is right here. Okay, look at that. Physics works. Love it when physics works. All right, now number 3. Number 3 is really tricky. So it says we got a stunt car, he's using the airbags, and he's driving at 25 meters per second for a total of 100 meters. Then he applies his brakes, and he accelerates uniformly. So uniformly is going to be key. And he comes to a stop just as he reaches the wall 50 meters away. So I want the position versus time graph and the velocity versus time graph. Now it does say sketch. So when it says sketch, it doesn't necessarily need numbers on it. So I'm going to start with no numbers, and I'll put them on as I get them just to kind of help things along. But you don't really need numbers on it because it is a sketch. So for the first part, I know this car travels at a constant speed and on a VT graph. I'm sorry, a position time graph. My position time graph, this straight line, this constant slope is constant speed. But then at some point, he puts on the brakes. When he puts on the brakes, he slows down. So he slows down in the positive direction. So I got to make this curved a little bit, and it's got to flatten out. So it curves up, and it kind of flattens out. So basically your graph should have this constant slope and a curved slope. Then for the velocity time graph, I know that he goes this constant speed for a little time. So on a velocity time graph, it's a horizontal line because the velocity does not change with time. But then he slows down in the positive direction. So I got to go back to 0. So I'm going to kind of just draw like so. And pause while I draw my line. So kind of like that. So it asks me how long does it take the car to travel the first 100 meters. So I can just do this with a little bit of just my calculations if I want to. So I know that it's not accelerating. So velocity equals displacement over time. So if I want to find time, it's just my displacement over velocity. So my displacement, I know he's gone 100 meters. And he was going 25 meters per second. So it's 4 seconds. So I know from here to here is really just 4 seconds. This will be 4 seconds from there to there. So then says, letter C says, remember that the area under a velocity time graph equals the displacement. We know that because we did it up here. Right? And we didn't forget that. The area under a VT graph is displacement. So let's look at this graph. So even though I know I made this because I knew what the ending was going to be, so this should be 8 seconds here. But I also know let's figure this out. They want the area of this. Okay, this is a triangle. So this area equals 1/2 base times height. But what does that really mean, right? This area is displacement, so I'm just going to call it delta x equals 1/2. What's my base? It's time. What's my height? It can be velocity. So I'm looking for time, so time is just going to be 2 delta x over v. So what do I got? I got 2. My delta x. My delta x was 50 meters. My velocity was 25 meters per second, which gives me another 4 seconds. Now you can also use the big 5 to do this. I'm not going to do it because it doesn't really ask me to, but you can certainly use the big 5 for it, and you'll still get 4 seconds. Now I did my graph, like that, so I'll get those 8 seconds, but up to these, like these 4 seconds. But even if you had your line like this, you could still do the same process. It just your graph wouldn't be as accurate. That's why they just said sketch it. So that's all I got. I will see if I can get my children to do a nice picture for you. Good luck on your RQA tomorrow.
Yeah, there's nothing more to see.
What are you drawing there, buddy? Oops, what happened?
Wow.
There it goes.
Wow.
What are you drawing?
Amazing.
You're drawing nothing. Want to choose a different color? You choose a blue one? Oh, very nice.
What's the eraser?
Where's the eraser? It's right over here, I think. Oh, no, there's the eraser. We're right there. Oops. Hold on. Let me see. There. Wait, hold on. There we go. You're going to choose blue again? That's your favorite. What are you doing now?
I'm drawing a sky.
You're drawing the sky? Are you going to put something in the sky?
Not clouds.
Not clouds? You don't want to put clouds in the sky? What do you want to put in the sky? Nothing is going to be in the sky? Okay. Okay, can you say good luck?
Good luck.